Amanda,
Yes.
what, what time is it?
Oh, it's bright outside.
It is 7 a.m. Oh my god, it's so early. Oh, the bus will arrive here soon. Come on, let's go.
Okay.
Oh, the bus is here already.
Okay, let's go. I wonder what's our first lesson? Chemistry, right?
Yeah. Hey. Hey guys.
How come you're late? Didn't you just come with me just now? Oh, good morning, teacher.
Okay, good morning, students. So today we are going to go to about...
I know. Today's the topic is on salt, right?
Yeah.
If I'm not mistaken, you told me today we're going to learn about how to prepare soluble salt.
Yes. So, Amanda, can you name a soluble salt?
A soluble salt. Okay. Example of a soluble salt, if I'm not mistaken, is copper 2 nitrate. Am I right, teacher?
Yes.
All the potassium salt, all the sodium salt, and all the ammonium salt are soluble in water. Am I right? All the group 1 and ammonium salt are soluble in water. Am I right?
Yes, you are correct.
I do study every day.
Okay, so good. So, I'm going to show you a video about the soluble salt, and it will be just 5-minute video, and hope you guys will learn more from it. Okay?
Okay, teacher, that's good.
When we talk about a salt, we don't just mean regular table salt. We are actually referring to a very wide spectrum of ionic compounds, or compounds of barium sulfate, used as a contrast agent when forming an X-ray image of the gastrointestinal tract, are insoluble in water. In this lesson, we will learn 2 different methods to form and isolate soluble salts. You have likely encountered copper 2 sulfate either as crystals or in solution, but have you ever wondered how it is made? Did you know that you can make your very own copper 2 sulfate crystals? Add 2 scoopfuls of copper 2 oxide, which is a black powder, into a beaker. Then add sulfuric acid so that all of the copper 2 oxide powder is covered and a bit more. Mix with a glass rod. Not very exciting, is it? But if you heat this over a roaring Bunsen burner flame while stirring, it turns bright blue. This is how you know that the reaction is complete. Let's remove it from the heat and let cool while we discuss the chemistry of this reaction. Copper 2 oxide reacted with sulfuric acid to give copper 2 sulfate and water. As copper 2 sulfate is soluble in water, a solution is formed. Copper 2 oxide is a metal oxide, which is an insoluble base, and as you may already know, sulfuric acid is an acid. So what has happened here is an acid-base neutralization reaction where a salt and water has been formed. An acid-base neutralization reaction is a type of a double displacement reaction. The copper and hydrogen ions have switched, much like how certain dancing partners can switch. Therefore, a soluble salt can be made by reacting an insoluble base with an acid. Referring back to your solution, you may find some unreacted copper 2 oxide powder that can be removed by filtration. Here is a mini challenge. How can we remove water without removing copper 2 sulfate? Please pause to think about this and resume when ready. We can evaporate some water right over the Bunsen burner flame. Then we can place the solution in a crystallizing dish near a windowsill and find that copper 2 sulfate crystals have formed. These crystals are bright blue, and you may notice that they have an irregular rhombus shape. We can also make soluble salts by reacting a soluble base or an alkali with an acid. We will make sodium chloride by titrating hydrochloric acid with sodium hydroxide. Remember to add phenolphthalein so we know the endpoint of the titration. Can you remember the correct color change? Pause and resume when ready. Phenolphthalein goes from colorless to light pink at the endpoint. However, we don't want pink crystals, so we must make note of the amount of sodium hydroxide used in the initial titration and repeat the titration without phenolphthalein. Here is a challenge. Can you write the equation for this reaction just as we did in the first example? Use a piece of paper and a pencil, pause the lesson, and resume when ready. The answer is, this is a double displacement reaction whereby the hydrogen and sodium ions have switched. As sodium chloride is soluble in water, what we get is a solution of sodium chloride. This is also an acid-base neutralization reaction, yielding a salt and water. Now, we can evaporate as much water as possible and let sodium chloride crystallize over the next few days in a crystallizing dish. Unlike the copper 2 sulfate crystals, sodium chloride crystals are white, smaller, and have a cubic-like structure. So there you have it. 2 soluble salts have been made by acid-base neutralization and isolated. To recap, we can form soluble salts by the reaction of an insoluble base with an acid and the reaction of a soluble base or an alkali with an acid.
Write some of the chapters together because teacher told us to revise the chapter.
Okay, sure. I will call you.
Okay, I will call you too. Bye.
Bye. I'll see you.